Have you ever heard of the term dimension? This term dimension is of immense importance in physics and in science in general. All right. Have you ever heard of the space that we are living in is a 3D space, which means that it is a three-dimensional space. What does that mean? Okay, and a plane is a two-dimensional figure, or a plane is two-dimensional in nature. A line, or a rope, that is a one-dimensional. Now, what is the meaning of dimension? Now, let me give you one example out here. Let us take an area. Let's say we have an area of a square, let's say, okay? Let's say I have a square like this, all right? Now, let's say the side of this is A and the side of this is A, okay? Now, what is the area of this square? We know that the area of the square is side square, isn't it? Side square, okay? So side here means A square, got it? Now, do you agree or not that the side is nothing but the length of this point from this point? Let's say this side, this PQRS, okay? This is the name of the square. And the side of the square is nothing but the length P to Q, right? And P to S. So therefore, instead of A, we can write this as length, okay? Denoted by L. So the length, this will be length square. Understand? Now, if you look at this power out here, now let us take another example. Let's say volume. Okay, let's say volume. Okay, so let's say a cube. Okay, you know what a cube is. A cube is nothing but a three-dimensional figure, all right, in which the sides are all equal. Okay, so let's say the side here is A, the side here is A, and the side here is A. It consists of the length, breadth, and height, all of equal sides. So what is the volume of this cube? Volume of this cube is length into breadth into height, and since the length, breadth, and height are all equal to A, so we have A into A into A, which is a cube. Yes, so again here the side of this cube is nothing but the length from one point to another point, or maybe from this point to that point, or maybe from that point to that point. So therefore, instead of A, we can replace it with L. So this will be L to the power 3. Understand? Now if you look at this power out here, this power here, so if the power of L is 2, then we know that it is area. If the power of L is 3, then we know that it is volume. What about a line? What about a line? If you have just a line like this, if you have just a line, let me use the same color since I've used white for all the objects. Okay, if you have just a line like this, then you have just length, isn't it? So the length here of the line is L to the power 1. You see here? So you get what so you understand where I'm getting at. So you see, you look at this power out here. L here, the power of L here is 1. So if the power of L is 1, then we are looking at the length, or we are talking about the length. If the power of L is 3, then we are talking about the volume. You understand here? So these powers are nothing but the dimensions, okay? So if the power of L is 2, that means area is a two-dimensional figure. So we write here 2D, two-dimensional figure, all right? Well, what else is a two-dimensional figure? A carom board, okay? The floor, the field, right? So any object or any shape that has only length and side, length and breadth, that is a two-dimensional figure. What about if the length, if the power is 3, then it is a three-dimensional figure like a cube. This is 3D. Okay, you can go right, you can go left, you can go front forward, you can go up down. Okay, so there are three ways. You can go either that way, you can go either that way, or you can go either back and front. So how many directions you can go? Three ways you can go. So for that reason, this is called a 3D. But the length, you can go only one direction, isn't it? Only either this way or that way. So therefore the power of L here is 1. So we say the length is one-dimensional figure. Is this clear? And if you note something here, length is nothing but a dimension, is nothing but a physical, a fundamental quantity. You remember it is one of the fundamental quantities, right? You remember or not, we discussed about the fundamental quantities. There are 7 fundamental quantities. What are those? They are length, mass, time, electric current, the temperature, luminous intensity, and amount of the substance. But I told you that in this chapter we are going to stick only to 3: length, mass, and time. So length here, it is one of the fundamental quantities. So what we can say that the dimension is nothing but the power of the fundamental quantities. Let me give you another example. Okay, because this involves only length. Let me give you an example which involves time also. Okay. So what about speed? How do you define speed? Speed, this is distance divided by time. Yes. So distance is nothing but the length from point A to point B. Yes. If I say distance, then it may be from point A to point B. Yes or no? So I can, instead of just distance, dimensionally, I denote it with capital L. Alright, and time I denote it with capital T. So here, if I take this T you get LT to the power minus 1. What is the power of length here? It is 1. So these powers, 1 and minus 1, these powers, 1 and minus 1, these are called the dimensions of speed. Okay, what about let's say let's say momentum. Okay, momentum on the other hand, what is the equation for momentum? We know that momentum is mass into velocity. Okay, so dimensionally mass is denoted by capital M, and velocity, its dimension is same as speed, so I have LT minus 1. So again, what are the powers of M here? 1, powers of L is 1 and minus 1. So these powers, 1, 1, minus 1, what are these called? These are called the dimensions. The dimensions of what? Of this particular physical quantity. Every physical quantity has different dimensions, not the same. Okay, just like now we have seen that the speed has dimension L t minus 1, and momentum has got dimension M L t minus 1. Understand? So how do we define dimension then? How do we define dimension? Dimension is nothing but the powers in which the fundamental quantities M, L, T are to be raised in order to define that physical quantity completely. Now if I change this dimension out here, if I, instead of 1, I write 2, let's say. Okay, instead of 1 here, let's say I write 2. So will this represent the dimension of momentum? No, it will not represent the dimension of momentum anymore. Okay, because why? The dimension, the power has changed. Got it? So what is a dimension? A dimension is nothing but the powers to which the fundamental quantities are raised to represent to represent the physical quantity completely. So this is the definition of dimension. Okay, all right. Now, in dimensional analysis, we use square brackets. We use square brackets like this. Okay, now this is a must. Suppose you want to find the dimension of force, then we put force inside of a square bracket. Now once we put force inside of a square bracket, it means that we are talking about the dimensional formula of force. Got it? So we are going to find the dimensional formula of different quantities. Okay, so let's start with number one, area or length. First of all, length. How do you define length? Length uh, inside of a square bracket is just L to the power 1. Okay, put this inside of a square bracket. Is there any mass out here? There is no mass, is it not? When I say the length of this stick is 1 meter, it means that I'm considering only the length, not the mass of the stick. Or maybe the length of this room is, let's say, 3 meters. Does that length has mass? No, it doesn't have mass, is it not? I don't say 3 kg. I don't say the length of this room is 3 kg. I don't say like that, no. I say 3 meters, okay? So because it does not have mass, I will put m, but I will put m to the power 0. All right? So L here is to the power 1. And does it have time? If I say the length of this room is 3 meter, I don't say the length of this room is 3 seconds, isn't it? So it doesn't have time also, so I will just put time, but I put it to the power 0. Is that clear? So here it means that therefore length has dimensions 0 in mass, 1 in length, and 0 in time. Understand? And this particular formula, this one, this is called a dimensional formula. Okay, so let us now find the dimensional formula of area. Number 2, area. You can take area of anything, right? Anything. Let's say you take the area of a rectangle. So area of a rectangle is nothing but length into breadth, right? So this is the formula for the area. So therefore area, put this inside of the square bracket, is equal to length. What do I denote the length with? Is it m, l, or t? I will denote the length with L, right? Because the length has the unit for, yeah, because it is meters, centimeter. Similarly, the breadth here is nothing but the length only, is it not? Dimensionally, what is a breadth? Breadth is like length only, but it is a shorter length. So therefore, I denote this breadth with L also, okay? So this will be L square. Put this inside of a square bracket. Always remember that once you put a square bracket on the left side, there should be a square bracket on the right side as well. Okay, is there any m out here? There's no mass, so m to the power 0, L to the power 2, t to the power 0. All right, so therefore area has dimensions 0 in mass, 2 in length, and 0 in time. Okay, so this is the dimensional formula for area. Let us go to okay, I told you I will give you, let's say another area, B, area of a circle. Do you know what is the area of a circle? Area of a circle is pi r square, isn't it? What is r here? R here is the radius and pi here is a constant. Okay, this pi here is a dimensionless constant, right? What is the value of pi? Pi is 22 by 7 or 3.14159. Okay, it is a dimensionless constant. You got the idea? Because it does not have mass, it does not have length, it does not have time, it does not have temperature, it does not have anything. It is a dimensionless constant. So therefore, once we write the dimensional formula, we have to put the square bracket. So when we put the square bracket like this, that means when we are writing the dimensional formula, do we put pi inside? We don't put pi inside. We put only r square inside of the square bracket. Now why don't we put pi inside? Because this is a dimensionless constant, and I told you already that once you put the square bracket, it means we are talking about the dimensions, right? We are speaking dimensionally. Okay, we are writing the dimensional formula. So we don't have to put any object or anything which is dimensionless. Okay, for example, this pi here is dimensionless, or any pure number 1 2 3 4, whatever, that is dimensionless. So if there is a number in front, always you will never put the number in front in this square bracket. Of course, in the formula for the area you can put, because it is the original formula. But as soon as you put the square bracket here, anything which is dimensionless you never put inside of the square bracket. I hope that is clear. Okay, and r here is the radius. Radius is what? Is it not the length from the center to the circumference? Yes, it is the length, isn't it, from this point to this point. So therefore this r I can denote it with L, so L square. You see? So again you have m0, L2, T0. So the dimension of area is the same as before. M0, 0 in mass, 2 in length, and 0 in time. Let us go further. Let's say speed. This is number 3, I suppose. Speed. Okay. Speed and velocity. Right. So how with what do you denote speed? You denote speed with u, isn't it? This is the initial speed. Okay, let me not do like this. Let me write speed itself. Speed is distance by time. So therefore speed inside of the square bracket, this will be distance. What is the distance? Distance is denoted by L and time is denoted by T. Okay, so you have L T minus 1. Do you understand why I get minus 1? Because if I take this T up, then the power of T here is 1, isn't it? It is in the denominator. If you take it up, then it becomes minus 1. Is there any m here? M here is, there's no m, so m0, L1, T minus 1. Hence speed has dimensions 0 in mass, 1 in length, and minus 1 in time. What about velocity? Velocity is displacement. Displacement by time. Okay, so therefore velocity inside of the square bracket, this will be displacement. Again, what is displacement? Displacement is with what will you denote displacement? M, L or T? Displacement, does it have mass? It doesn't have mass. Does it have time? Displacement is just the distance from one point to another point, is it not? And that is nothing but the length. So L and time is t. So again you have Lt minus 1. So m0 L1 t minus 1. Got it? So you see here that speed and velocity, they have the same dimensions. Okay? And why they have the same dimensions? Basically because they have the same units. Or you can say that because they have the same dimensions, they will have the same units. What? Meter per second, kilometer per hour. Yes or no? So that is another thing that you have to remember. Any quantity having the same dimension, or having the same dimension formula will always have the same units. Okay, let's go further. What about number 4? Acceleration. Acceleration. How do you define acceleration? Acceleration is velocity divided by time. Okay, so therefore acceleration inside of the square bracket is equal to velocity by time, this also inside of the square bracket. And so that means the dimensional formula of velocity. What is the dimensional formula of velocity? Just now we found out. It is this. Okay, we can write this, but let us not write this for now. Let us write this one. Lt minus 1. So you have Lt minus 1 divided by time. Put this inside of the square bracket. So L, this t, if you take it up, this one which is in the denominator, if you take it up, it will be minus 1, isn't it? So you'll have t minus 1 into t minus 1. So that will be t minus 2. Is there any mass here? There's no mass. m0 L1 t minus 2. Hence acceleration has dimensions, 0 in mass, 1 in length, and minus 2 in time. Is that okay? Let's go further. What number was that? Number 4. So this will be number 5. Number 5, momentum. What is the formula for momentum? Momentum is mass into velocity. Okay, so therefore momentum inside of the square bracket. Please don't forget to write the square bracket. Okay, I've seen many people, maybe they are being casual or being lazy, they don't write the square bracket, and if you don't write the square bracket, then the meaning changes altogether. Because if I write this and this, okay, let me write this. Okay, these two equations, this one and this one, is it the same or not? If you just look, it may not look the same, but then physically it is very different. This is the formula for momentum, but this is the dimensional formula for momentum. Okay, so therefore you have to write the square bracket. So mass here is m, and velocity is what? I think this one. Yeah, velocity is Lt minus 1. Lt minus 1. Yes, what is the power of m here? M here is 1, L here is 1. So therefore, momentum has dimensions. 1 in mass, 1 in length, minus 1 in time. Okay, have you got the idea how to do?